I really like this question. If you're not sure where to start, then I would just suggest creating a prism that's not like too simple. I think a cuboid won't particularly help, but something like a hexagon can give a bit of insight into this problem. So here I've clearly got one face, and then my prism means it's a hexagon repeated throughout space. It'll look a bit like this. And at the other end, there's going to be another hexagon like that. Okay, so there's going to be another face, and then every single edge is going to also create a face here. So there's going to be another 6 faces. Now, I've got 8 faces in total, but that kind of tells me, therefore, that actually, right, I'm always going to, for a prism, I'm always going to have a face at the end and the other end. And so actually what I need is 8 faces in the middle, and that's going to give rise not to a hexagon, but to an octagon, which looks a bit like this. So that's going to give me a face, and now I've got 1, 2, 3, 4, 5, 6, 7, 8 that are then going to combine with the rest of this octagon. It's enough to tell me what's going on though, but it's definitely going to be now 10 faces. Well, how many edges do I have? There's going to be 8 edges from this octagon, and then another 8 from the one at the other end. And then every single vertex, of which there are 8 as well, is going to join with the respective vertex over here to create another 8 edges. And therefore we've got the answer. It's got to be 24. So I hope I've convinced you of that. You know, work out that it's an octagonal prism, that's the main bit, and then carefully consider the edges, 8 here, 8 at the other end, and then 8 where they're joining the respective vertices together.